Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at something I spotted on the Banggood website. It's something I've bought with my own money, not sponsored or anything, and it's an adapter that turns your oscilloscope into a curve tracer. So I thought it's not too bad a price, looks alright, I'll take a chance. So I ordered it. So let's go to the bench and have a look at it, and then we'll have a look at what a frustrating experience it was altogether, but that's for later. For now, let's just go and have a look at exactly what this thing is. Okay, so here's the device in question, and the version I've bought is the single channel, and it's got the two pieces of acrylic either side. For the most part, the PCB looks quite well made, but it hasn't been properly clean. There still is an example of flux residue on there, so at some point I'm going to get those screws out and just give it a clean with IPA, because obviously the flux is by definition corrosive. So on the top we've got a load of different settings, and although it won't show up terribly well in this view, all the semiconductors, well certainly this one, those two, and that DIL IC there, have all had their numbers lasered off. I don't know why they do this. I mean, I've seen it in other stuff as well. Presumably it's so that it makes it difficult to copy. Well, there's got to be an irony there, hasn't there? Because I think the Chinese tech manufacturer's hobby is copying, so it's ironic that they're not very keen on anybody copying their designs. Now I'm sure somebody a bit sharper than me would be able to reverse engineer this. It can't be that complicated. That's almost certainly some kind of voltage regulator, and I guess these are op amps, possibly that's a dual 555, who knows, but somebody does. But yeah, so that's the circuit board, and what I'm now going to do is I'm going to attach it and try and calibrate it, but I won't show you that because I've tried before and failed, because quite frankly the instructions are extremely frustrating. We have a couple of pages of A4, and certainly this is been translated into English. I won't say it is in English. It's understandable, but then there are a number of diagrams. I'm showing you these isn't the version I've got, obviously, and the labels are in Chinese. So let's just have a look at, this is the diagram for the dual one, and if I just keep that still there, you hopefully can see that. Yeah. So these labels here are in Chinese. Now I'm ashamed to say that my Chinese reading skills are zero, but it's a little bit bizarre because they have done some translation. We've got some numbers there, 1 or 2 letters. We've got 24 volt there, channel 1, channel 2. But what does all this mean? It would be very, very handy indeed to know. Well, I've taken a very high-tech approach to this. So this is my version, which is a single channel in acrylic casing. And what I've done is, because you can download this from Banggood as a Word file, what I've done is I've pasted these Chinese characters into Google Translate, and I've written on here in green pen what Google Translate says these characters mean, and certainly some of them make sense. Interesting, this one here is called road signal transmission. Not entirely sure what that means. I know it's the positive terminal, and you connect the component between red and black, so presumably that just means the signal. But I've translated those, so if you've got a different version, you should be able to make use of Google to do that, and that will work okay. And I've scanned that, so I'll just put an image of the scan on here, so you can just look at roughly what we've got, and if you want to pause the video, if you're going to get one of these things, it might help you, but just use Google Translate and you'll be okay. Now I have read on the Banggood website there's a few comments about it's difficult to download the manual. It's actually a Microsoft Word file, and what I had to do in the end was I had to right click on the link, save target as, and straight away my Windows 10 wasn't very keen on me downloading it at all, so I had to click past the warning that it was potentially harmful, and eventually I got a Microsoft Word file saved in my downloads, and that's where I've got this from. But actually, certainly on my version of Windows 10, if I click on the link, it appears to open but then doesn't, so I can understand some people would be struggling to understand what it is that why they can't download the manual. But yeah, there you go. I really don't get why here it says signal output channel 1, yet here we've got channel 2. Okay, I can pretty much work out what that was, but what's this? Well, actually it's the horizontal and vertical line signal output adjustment, and yeah, there you go. Now the version that I've got doesn't have some of these components, and I notice this has got a multi-turn pot here for voltage regulation, and actually on this one there is a place where the multi-turn pot would have gone, but it's now replaced with two SMD resistors instead. So there you go, that's it. Right, I said it was extremely frustrating getting it to set up, and indeed it is, so I won't bore you with that. But what else do you get with the kit? Well, you get a power supply, a bit of a wall wart power supply. This is it. It comes with a, if I can get it undone, the American style connector, and this is an adapter to the UK plug, so it works fine with that. It is actually 24 volts output, this power supply, so you do need quite a high voltage, and that goes to a barrel jack which attaches there. You get a couple of probes, and then you also get two short BNC to BNC leads to connect the scope, sorry, to connect the adapter to the oscilloscope. So that's the basic setting. Frustrating documents, and you know, just find it bizarre that they want to laser off the numbers, but hey ho, you know, maybe they don't want to be beaten at their own game when it comes to copying things. I'm sure I'll not be very popular for saying that, but you know, that's what happens. Okay, well there's the description of the item, and I put a couple of close-ups in for you so you could see the circuit board, and you could hopefully make out the little bits of flux residue as well. I'll get those cleaned off now I've done the photography, and it can hopefully that'll make it a bit more durable over time. Then what a frustrating time I had attempting to get the thing to actually produce some meaningful results, and I tried with the instructions and didn't get very far. And maybe it's me, I'd be the first to accept that you know, I'm not a great electronics expert, but I struggled, and then I hit on an idea, which was if I was to use a very distinctive shape component in terms of the curve trace it produces, that might allow me to at least start coming up with some results. So that's what I did, and it worked. So first of all, we'll have a look at my analog oscilloscope, which has a built-in curve tracer, so we can see exactly what it is, and then from there we'll go to the bench and have a look at the Banggood curve tracer adapter in action. And I'm going to apologize in advance, because on the second video clip on the bench we start out of focus, but very quickly when it gets to the bits that matter, the camera does eventually make its mind up and decide to focus. I should have been a little bit more on the ball, but I was struggling a little bit with the will to live at the time, and I couldn't bear the thought of shooting it again, so apologies for that that laziness, but the focus does fairly quickly snap in, and you can see the bits that matter. Right, let's look at the Hameg scope, and then we'll look at the Banggood adapter. Okay, if you're a keen watcher of the channel, you've maybe seen this in a couple of previous videos. This is my Hameg HM307 analog oscilloscope from the 1970s. It's a single channel scope. It does have an X and a Y input, so it is possible to do it in XY mode. But what I want to do here is make use of another feature that this scope has, which is here is called the CT, but actually it's a curve tracer built in. So I've just got the scope running now, and these time base and amplifier settings don't actually matter right now, because we're going to make use of these two connections here. Now I've got a 4.7 volt Zener diode connected across these two, so let's switch the curve tracer on. And if you're familiar with curve tracers, you instantly recognize the very distinctive shape that is a Zener diode. So we've got the conventional about 0.6 volts reverse bias knee there, and then across here we've got the Zener forward knee, which is 4.7 volts in this case approximately, and you get that very distinctive trace. So that's something which would be a good pointer to whether or not you've got your curve tracer set up correctly. Now this doesn't have any settings, you just switch it on and it works. So let's now swap the Zener diode for a 1 microfarad capacitor. In this case it's non-polarized. I'm just going to attach the leads while I'm talking, and we get that characteristic elliptical shape, and that changes depending on the value of the capacitor. But I think the important point here is the Zener diode, which is a very distinctive shape. A conventional diode doesn't have the that second forward knee. So having shown you that on a scope with a built-in curve tracer, let's now go back onto the bench again and look at this Banggood adapter and see if I can make some sense of it by a different means. Okay, here we are back on the bench with the Banggood curve tracer adapter, and this is the same Zener diode as I've just shown you on the Hameg's built-in curve tracer. And what I did was essentially put this diode in circuit, and I just kept on fiddling with the settings until I got something that looked like a Zener diode. Now I appreciate that isn't remotely scientific, but it worked for me, so it'll do. Certainly the other methods were extremely frustrating. So what we've got there, we've certainly got the reverse bias knee there, and we've got the forward bias knee there, and if it is possible to make those legs longer, but if you do, you start to get erroneous results on other things. So here's the 1 microfarad capacitor, which I also used with the Hameg curve tracer. So let's put that in circuit. Remember, we got that characteristic ellipse shape. So let's now attach that, and hopefully you can see, yeah, there we've got an ellipse. Maybe not exactly the same shape, but yeah, no question, this certainly is working as a curve tracer would do now. So yeah, it does work, but what a pain in the neck it was to set up. Or maybe it's just me who isn't bright enough to realise some of the subtleties, but there you go, it does work. And I'm pleased to say it works with a very simple oscilloscope. I deliberately wanted to use this SOE because it isn't in any way a flashy scope, but it does allow you to extend the possibilities of an instrument like this and use the two channels as I have here to produce curve traces. Now I appreciate you're going to say to me, yeah, but you don't really look exactly like it, does it? Well, we can adjust the frequency. So if we go to the lowest setting, I personally think that looks suspiciously like it. If we go back to where I was showing you just now and then carry on up there, eventually we get the ellipse like that, which would appear our resistor is. So there is, you know, some latitude in these settings, but that's probably the nearest to what the Banggood made. So let's just pop the Zener back in and see how the Zener looks at that setting. Well, it would help if I put it the right way round, I suppose, or the same way round anyway. So there we go. Yeah, so we are still getting the two knees, not incredibly obvious there, but you can see it. If I go back to the speed that we were looking at before, it doesn't make really any difference. In fact, yeah, frequency doesn't make too much difference to this, but that's understandable, because the diode doesn't really have well, it does have capacitance, but it's very small indeed, whereas clearly the capacitor is having some effect on the speed of the oscillation, I guess. So there you go. It does work, but what an extremely frustrating time I've had trying to get it to work, and it doesn't help that my Chinese reading skills are non-existent. Okay, well, you've got the curve tracer adapter. Hope it's made some sense. It also includes instructions to allow you to attach it to an analog oscilloscope. I've not bothered to do that, mainly because I suspect people buying this these days are going to have a digital scope, and in my experience it's a little bit harder to get these things to work with a digital scope than it is with an analog one for some bizarre reason. But there you go. It was interesting. I'll put a link in the description to the item that I bought. Be aware that it's just a link to the description. I bought this with my own money, and I certainly don't make anything if you choose to buy one. It's an interesting device, and I'd be interested to hear if anybody else has had a bit more success than I have. I really do need to seriously consider a course in Chinese, I feel. Or maybe not, I don't know. Anyway, thanks very much for watching. Hope you've found it amusing, if not enjoyable, and look forward to seeing you on the next video.